Hello, can you hear me? Good afternoon. Good afternoon. Nice to see all of you here. And welcome to our little panel about cloud native and what all that could mean to developers, especially to Java developers. Before we start, I would say we just shortly introduce ourselves. Maybe Jessica, you start.
Sure. My name is Jessica Dean. It's great to be here. Thanks for having me. I'm a cloud developer advocate for Microsoft, and I tend to focus on cloud, DevOps, Linux, open source.
Hi everyone, Dan, I'm good actually, I'm mic'd up.
Oh,
yeah,
thanks. There we go.
I can speak lots, brilliant. Yeah, hi everyone, Daniel Bryant, independent tech consultant, working with DataWire quite a bit at the moment. Java background, very much, but these days increasingly Opsy stuff as well. So plenty of experience in Kubernetes, Envoy, Cloud Foundry, all that good stuff.
Cool. Wow. So Steve Paul, I work for IBM. I'm a developer advocate for the Java Runtimes team. I basically work JVMs up, so I'm on the other side of the glass to you guys.
Hi, I'm Martijn. I'm the CEO of JClarity, so we're, I guess, a cloud-native shop. And then on the community side, I sit on the Java standards body, and I run Adopt OpenJDK.
Thank you. Okay, so the idea of this conversation was because we just, when we were preparing this discussion, we found out that this Java community, this is you, have been tremendously successful over the last 1.5 decades, yeah? With their model to build and to deploy models, to follow a certain, let's say, 3 or multi-tier architecture. There's a database, there's a server, or call it an application server, and then there's a client, mostly a browser, sometimes a Swing client. And with that model, all of us have been extremely successful. But now comes the things called cloud. Well, not now, it's already there since many years, yeah? But now it's getting really serious. More and more companies and more customers, more and more users really getting into the game, and the world is speaking about cloud native. And we'd like to find out a little bit what the hell does cloud native mean, especially to Java developers, for your personal career, for your advice you give your customers, and of course for the general idea of Java-based software architectures. In order to prepare this conversation, we said, okay, there are a few types of cloud. It's a very rough categorization, yeah? And maybe it's not in all the details correct. But first of all, it was our intention to find out where you are. Yeah? Where is your main practice and experience in the, let's say, cloud world? And first of all, we'd like to ask you, maybe you show up your hands. Do you mainly deploy applications into a public cloud? Okay.
More than we thought.
Okay.
That's quite good.
That's awesome.
Cool.
Amazon still needs to get a lot more money.
You could use Azure.
Or Google.
I can give you some free credits.
Number 2, you're using certain, let's say, cloud provisioning technology, but not only in the public cloud, but maybe in their own data center, on their own bare metal thing, etc.
On-prem?
On-prem, yes. Okay? Yeah. Next one. You are deep into the Docker Kubernetes obsession. Okay, some more? Wow, interesting. You're mainly consuming existing cloud-native services, such as, I don't know, identity, data storage, some more examples.
Machine learning, cognitive services, tying into APIs, maybe in your applications.
And last but not least, your main business is run on function as a service, or called serverless.
Also put things like App Engine in that one, or Elastic Beanstalk maybe as well.
Very few. Okay. Quite a balanced view, but of course, but that's what we expected. Number 5 is still very early stage. Okay, yeah, the basic idea, as we said, is this Java community comes from a world where we deployed WAR files, ER files, jar files, yeah, and brought it to a runtime, and now things are changing. First of all, Martijn, maybe from your perspective, what is the key learning a Java developer? What would you recommend a Java developer who is not familiar with these cloud things yet? Should he or she learn or have a look on it?
You're absolutely going to have to look at it. Putting on my CEO hat, I want my engineers to build stuff for me faster so I can sell it, so I can make more money for my stakeholders, because we're an evil capitalist company, and we're not ashamed to be one. So you absolutely will, you are going to get pushed into this mold, right? So there's a lot of other language ecosystems out there, the Python people, Ruby, Python, Go people, Rust people, who are sort of, I guess, newer communities, and they're more familiar and they're more up to date with the cloud native stacks that are going on today. But your businesses, your business leaders will be pushing you down this path. The thing that you really need to start getting familiar and comfortable with again is the command line. That's where it all starts. You really need to go back, start learning some of the basics of the command line, because a lot of the tooling in this space, it is getting better, it is getting easier to use, but a lot of it defaults back to the command line. That's a great starting point.
Yeah, I'd agree with that. It's very much, you've got to get out of the Java ivory tower and start looking at some of the technologies that are out there. So Docker and things like that are just really important for you to get your head around. Not necessarily completely command line driven. There are a few UIs to help. Yeah.
One thing I'd say is, Steve and I actually did a talk a few years ago at Java 1 on this one, is what Martin Thompson calls mechanical sympathy. So as you're kind of moving to the cloud, recognize that things are a lot more ephemeral, as in things die, they come back up, latency on the networks, even things like Docker, pre-Java 9, the JDK doesn't, or JVM, sorry, doesn't always respect the C groups, the kind of way you define the resource management. So I'm writing a book, shameless plug, check out the book for more info, but as in you can totally find a bunch of stuff online as well around if you are going to use Docker with Java, pre-Java 9 in particular, you want to do a bunch of reading around C groups and around memory and a bunch of other things as well.
Awesome, yeah. So what everyone else said, but I think also one of the biggest things is be comfortable with the fact that you don't know, that you, I mean, no one's going to know everything, and if this is still something that's scary or something that's new, that's okay, and that's normal. I think everyone who's been up here, there's still certain times, there's new technologies that are being released so consistently where it's like, oh, there's a new tool, how do we use this? So it's okay not to know, but be comfortable also with being willing to, I guess, go and learn. And there's tools that are being put out to make some of this simpler, to make it simpler for Docker and Kubernetes.
Yeah, so Jessica, just before the panel, showed Martin and us a new tool, and it's like, yeah, this is really cool.
Yeah. And it's funny because like these new tools are being released all the time. I'm just talking to you about Ambassador. I was like, oh, that's built on Envoy and Istio, and he's like, oh, well, there's actually this, and there's, no one's going to know everything. So just be comfortable with that, and then accept that there's no shame in that, and it's okay to be scared, but still being open to learning.
But the Java community has extremely been used to not look at the infrastructure. So I think there was especially in the Java enterprise world, there was a culture of more than 10 years. Don't look to the data store. It's a black box. Just use an ORM to get to it. Don't look to the infrastructure because you've got a garbage collector, you've got a VM, yeah? Everything is abstracted, yeah? Don't care about that. And now things are changing. To which degree should I, as the Java developer, get into those infra questions?
I would say
do I need to become an expert in all that stuff?
So from my perspective, which my background is also ops, be aware of it, know that the infrastructure and the architecture exists. You don't need to do my job, just like I don't need to do yours. So be aware that the infrastructure and architecture, and maybe as you're dealing with Kubernetes, ingress controllers, that they exist, but you don't have to understand deep networking or deep layering.
Yeah, I'd also, great point, Jessica, I'd also add on that one of the challenges I think we all face now is there's so much cool tech and so many cool platforms out there, it's matching to your use case. So I'm a massive fan of functions, Azure functions, Google functions, take your pick. I like App Engine a lot. I like Elastic Beanstalk. It's actually very nice as a halfway kind of house for Java. I can deploy a war onto Elastic Beanstalk. Tomcat is all abstracted away from me, and that's great. So you don't need to run your own Kubernetes cluster. You can if you want, and maybe you've got certain requirements, but to Jessica's point, there's many hosted options out there, many specialists, many experts that are really good at running the platform. Think about what your business does and where you add the most value. Is it building a Kubernetes platform, or is it deploying a jar onto App Engine, for example? I think that's one of the hardest choices I face as an architect developer. Yeah.
So I'd come back to something you said right at the beginning. We talk about public cloud, and we talk about it as being the cloud. And a lot of you may go, I don't have to worry about that because I don't deploy to public cloud. But public cloud is driving this whole new way of thinking about deployment. So there's a whole bunch of new set of economics. And that's driving some of the new tooling, all this stuff. And that's going to come to you. Even if you don't go to the cloud is going to come to you locally. You're already probably doing it with Kube in some of these places. But it's inevitable that the demands of cloud on how we design applications and how we deploy are all going to come to you. So one way or the other, you've got to start thinking out which bit do you want to go learn. So I would say, if you don't learn Docker now, then that's a mistake. Docker's the easy bet. And then at some point a bit later on, when you've got your head around it, maybe you try Kube, but you need to start thinking about it.
The other major gotcha is architectural concerns. So you need to start thinking about where your code and where your data is actually running. So for a lot of people now, they run in the same data center with their database co-located with their app server, and everything runs just fine. Cloud providers suck. The open internet sucks. Everything breaks and falls over constantly, and stuff is much, much further away than you think. So we had a classic case of a customer the other day who'd moved to their shiny new cloud platform where they were logging all their stuff to a logging service. They didn't realize they were logging every single log line across Australia over a satellite link because they were just using a cloud service, right? So stuff like this can absolutely kill your application when you migrate. So you really have to start not just thinking as a developer in your app, you have to start thinking like an architect again as well. So looking at your physical and logical diagrams, where stuff is really important in this new world.
I think that's one of the benefits of getting comfortable with Docker, as you said, is now you're setting yourself up to where your stuff is immutable and you can move it kind of wherever you want. And then using these kind of core technologies, you're not locking yourself into one particular cloud platform. I can deploy my application on Azure, on Amazon, on Google, on IBM. It really doesn't matter, which also gives me more redundancy and ability to fail over. So if one cloud provider does go down and I have a multi-tenant or multi-cloud kind of scenario, my application, my delivery, everything's still up and it doesn't impact me negatively. So I'm able to maximize my delivery and my value I offer my customers by utilizing these technologies and considering about that architecture.
Yeah, and so you were talking about over satellite. Was that customer paying for that link?
Yes.
Okay, so they suddenly discovered that they had a big bill. Yeah, so that's the other thing that comes out of this cloud is that you've got to have flexible designs because the economics change. You just find you have to do things differently. And as you say, it's also high availability, you have to resilient systems. None of that are things that we're used to designing Java applications to deal with. And it's still not something that Java is designed to do. It's going to be coming down at the layers below that, which is now becoming more and more something you need to be aware of.
Something I just thought of as we everyone talk about architecture is security concerns as well. I know Steve's talked quite about this in the past. The sort of the attack modes, the attack surfaces are wildly different in the cloud versus on-prem. A lot of the on-prem stuff assumes the kind of Death Star model, you know, the kind of hardened edge, but if you're on the inside, have at it, yeah? Whereas we're moving now towards more zero trust networks in that everything is its own thing, yeah? You shouldn't be able to breach a network and then just completely, you know, suck up all the traffic internally. So I've learned a bunch from the Azure docs are actually really good on this. I've learned a bunch recently from the Azure docs. The AWS docs are quite good, talking a lot about the shared security model, as in the platform provides a certain amount of security protection, but then it's a shared responsibility. You're responsible, I'm responsible for making sure my dependencies are up to date, making sure I've hardened the boxes as well as the actual perimeter and so forth. So architecture and security, I've been caught a few times on learning new stuff. Just I had to admit, don't know that, got to spend a day figuring out how this new model works.
I have one more question about the thing, Jessica, you just mentioned, you said you want to be free to move to whatever platform, but this requires being on Docker and Kubernetes? Or because on the other hand, there are lots of people saying, wow, we're coming from the Java world and we are obsessive about avoiding a vendor lock-in, and now come the platform providers, be it IBM or be it Microsoft or be it Google or be it Amazon, etc. And now they want us to be stuck into their platform.
Yeah.
So what do you think about this, let's say, challenge or problem, or on the other hand, doesn't even exist?
Yeah, great question. So just by a show of hands, how many people in the audience have ever handed your application, your jar file, everything over to your ops team, and then you get an answer of, it doesn't work? And your reply is, but it works on my system. Yeah, everyone's hand should go up. So I mean, that's a standard issue, right? It works in some environments because you might have all your dependencies. You've set up your development platform to work and to support it, and then you go and try to move it, and it's not portable. It's not movable. So then how can I even consider taking that application and moving it anywhere, not even the cloud? I can't even do it on-prem if I have that model. It's not immutable. Using cloud-based technology sets you up for that microservice architecture and sets you up to make your delivery portable and resilient. So I'm not saying it's 100% necessary, but it's, if you want to alleviate that pain point and solve that issue, that's the easiest and probably most common way to do it right now, unless you, I don't know, I guess want to set up a shell script or something and customize every environment you're deploying to, which just sounds kind of backwards. So.
I agree, exactly. Containers.
Yeah.
Yeah, I think two APIs we're seeing really popular is the Kubernetes API and the Envoy API. So if people haven't heard of Envoy, it's a proxy, kind of a communication proxy. So and I think people are standardizing around those APIs, the things of Istio. A few of you bumped into Istio as a kind of communication mechanism, as a service mesh. So I think Kubernetes combined with Envoy is now the new cloud brokerage layer. If you can run something on Kubernetes, it should run on a GKE, AKS, take your pick. The lock-ins are the data services and the security, the IAM. And yes, you're locking in, but there is, I think, in the past, I've definitely put too much value in abstracting things. To Sebastian's point, I wrote multiple ORM interfaces, so I could swap out my database, supposedly. I never once swapped out my database. I did about 10 different interfaces over different projects. So recognize that lock-in is not always a bad thing. By using DynamoDB, by using Cosmos, by using the APIs or whatever, I get a whole bunch of advantages. It's a trade-off. Yes, it will be hard to migrate away from some of these things, but by going for the lowest common denominator, I often have a very poor user experience. So for me, it's a lot about trade-offs, I think.
And by the way, for those who don't know, Kubernetes is an open source container orchestrator, and it's fully extensible. So when he talks about how Envoy is tying in, you're setting up custom resource definitions to tie in Envoy's APIs over into the Kubernetes system. And you can do that with other tools as well. That's one of the beauties that makes it so large. And sometimes it can get very complicated, but it also makes it powerful to tie into that and then be able to use it with any cloud provider platform.
So the thing we found going multi-cloud, that the two things that can and will kill you, if you're even medium-sized data or big data, once you have locked your data into a particular cloud vendor, it's pretty much stuck there for life, right? It is almost impossible to get terabytes of data out of a cloud vendor unless you turn up to their data center with a van and 5 million permits. Yes, we have done this, by the way, and it's quite good fun. The other concern you have to have a look at with your cloud vendors is whether or not they support all the various international jurisdictions on data and data privacy, right? So with GDPR and with other laws coming into place, you really need to make sure that your data isn't locked in a particular place in a particular way, which then gets the government regulators on your back, which can also definitely happen. So you still have to pick your cloud vendor and your sort of semi-lock-in strategy very, very carefully.
So we're just turning people off from the cloud now, are we? Don't use the cloud because it's scary. So we put these questions. How many of you feel that you need to understand cloud? Come on, yeah, okay, cool. Right, and how many of you feel that you've got to do something with deploying to cloud or using cloud technologies, say, in the next 12 months? Yeah, yeah.
How many of you are scared of the cloud and scared of this new learning curve? I guess I wanted everyone to kind of raise their hands, including the people up here on the panel, so everyone can see you're not alone in that fear, and you're not alone with this learning curve. This is still an area of technology that's being defined, that's being grown. For everyone who's so obsessed with Kubernetes, because I feel like it's such a buzzword these days, it's not the thing. It's the thing that gets us to the thing. So it's only one step, but it's a step we have to take now to get comfortable. It's okay to be scared. There are certain tools, as I was saying, shameless plug. I have a session later on today. I was telling Steve this earlier, but there's tools you can use to simplify your learning curve and then reduce that fear.
Is there any question from the audience? Because there are Debbie and Soraya with microphones and can help. Any comment from your side?
Can I just do one shameless plug? Well, that was in something just
All your plugs are shameless.
No, as in like not for me this time. But one thing I found useful, I can only speak to Amazon because I mainly do AWS stuff. I'm sure Azure, and I know Google are looking at this stuff. But I did my certifications last year on Amazon AWS, DevOps sysadmin associate, something pro, and certificates have got a mixed reputation. But I actually learned a bunch. Yeah, I used A Cloud Guru, very popular website. You get like a couple $100 or whatever, or pounds. Get access to all the videos, and it took me a fair chunk of time, to be honest, like 40 plus hours to go through all the videos and learn, but it really level set me, yeah, and I, as a consultant, I found it super useful to now explain the sort of cloud at various levels. So certifications, not all of them are great in my opinion, but I can speak to the Amazon ones, and I'm sure the other cloud vendors are copying some of the same ideas. I really went in depth into Amazon. I learned so much about the platform, how things join together, how they work behind the scenes, and it really helped me a bunch. So I totally recommend whatever cloud you're going for, dive on into the learning resources. I know AKS, the documentation is actually fantastic on
We work on the docs team, so yeah, we try that.
It's super awesome, yeah. And Google, I know, are doing their cloud architect certificate. So I'll try to be cloud neutral, but do read these things. I found them genuinely really useful, yeah.
Any comments? Yes, please. Please wait a second for the microphone.
We just talked about being cloud agnostic, and when we, for example, in our company, when we're using AWS, we're using a lot of AWS things like database and stuff that is really related to AWS, and the more we use it, the more we are like locked into AWS. So how do we get over this? If we are using cloud and there are so many cool things like Kinesis how do we get out of it?
You don't. Quite seriously.
If you're using something that works for you, you don't have to change. I guess when I was saying like not being cloud agnostic or not being locked in, that's obviously coming from the perception that maybe you're not using cloud or you don't have big data. If you do have big data, as he said, you're not getting out of it, and your data's stuck. If you are still new and you're researching, figure out what maybe has the best offering. From a database perspective, I mean, a lot of clouds are pretty similar, right? We're all going to have our own database offerings. We're all going to have our connectors, our cognitive services, our different APIs, our serverless. There's no best answer for everyone. I can have my bias. He can have his bias. We're all going to maybe lean a certain way. But I think the one thing we can all agree on is that cloud is here, and just be aware of that.
So, yeah, I second that. The other thing to think about is when you move from one cloud to the other, it's not just a technology move, it's a cost change, because people have different payment methods and different costs. So it's not just, oh, I'm going to move. It's also, when I move there, will it cost me less or more just by moving from one tier structure to something different there? Every cloud does it differently. So you end up being locked in for two reasons. One is you've used very specific technologies, and the other thing is you've tuned your application to the price model of that cloud.
And then on top of that, there's also a cost basis from a personnel perspective, from the learning curve. So the time investment. If you do switch, which, I mean, I have colleagues that have worked on projects where people leave one cloud and then come over to Azure. And I'm not promoting that. I'm just saying that happens. And same vice versa. People will leave Azure and go to different cloud providers. But in any scenario, you're now having to learn a different cloud. Whereas I know Azure command line very well. If I go over to Amazon, I haven't touched the AWS command line in like 3 years. So there's going to be a learning curve there in addition to the cost from a per minute or per second or microsecond billing perspective.
Some more questions or comments from the audience? Oh, please here.
So I'd like to ask the panel on comments on Java in the cloud, and like lots of people talk about startup time and memory usage, and it's never going to work in cloud environments. So what do you folks think?
So come to my talk later today.
You can also come to my talk later today. We'll do a demo with Java. Though if our sessions are at the same time, you don't have to feel like you have to pick.
So I've got a story for you about some improvements that the Eclipse OpenJ9 could give you, but you are quite right to call it out as a challenge. And so the Java community is looking hard at how we deal with this. So it's like, how do we change the way that we create code? How do we change how quickly we deliver it? How do we get new ideas into the system? So we are, the people who are investing in the creation of these things are looking hard at how we make sure that Java and the JVM continue to evolve for the cloud, right? But we're at the same position with that as all of us are about what's the cloud going to finally look like. So we're still exploring.
I think one of the other things, to go back to kind of containers and orchestration, is when I am using a Docker file or a Docker container or pushing on Kubernetes, once I have it built, and because of the way how Docker works when layers are cached, if I'm running it in a Docker container on the cloud, that my performance is based on whatever my Docker file is required, or if I'm using Maven or whatever I'm using as part of my platform. So in that instance, once it's up, once the layers are cached, I'm not bound by maybe those same challenges. The hard part is, though, and I can say this even from my own demos, is when I do have to build and compile a Docker image and I change one thing and it's recaching that layer, obviously because the packages are so much larger, that build time takes more time, but the run time is going to be the same no matter what after it's built and cached.
I think one thing that's quite interesting, I was chatting to Sebastian earlier on around the JVM has spent, or the team working on the JVM has spent 20 years optimizing for a kind of monolithic, long running time, jitting everything and so forth. But now we are starting to see publicly and also privately, I know some rumors of innovation in the JVM is focusing at different things. So Steve's talked a bunch around this, ahead of time compilation versus JIT. So optimizing up front, you don't get a bigger hit, but you get it ahead of time. Things like class data sharing, like CDS I think it's called. So you can basically, if you're sharing things like Lambda style functions, you can share preloaded class files. And there's a bunch of stuff going on in JVMs. Amazon have got their own JVM team. I know that. I'm sure Azure have got their own JDK team, for example. I think we'll see the innovation go towards that rather than optimizing for long running and JIT and so forth. I think the innovation on the JVM, give it a year or two. It's like turning a big tanker. But I do think the Java is too pervasive for us to walk away. Yeah, and we're all passionate about Java here. So I think the industry will adapt to some of these challenges. I know Amazon are doing a whole bunch of stuff around the Azure, Amazon is a whole bunch of stuff around Lambda in particular, the sort of demands on how Lambda start up and run and so forth. I know they're spending a lot of time optimizing that.
So the best you can do today is use Java 11, JDK 11, put it onto an Alpine Linux-based Docker container, and use the JLink tool that's come with Java 9+, to actually completely minimize the Java runtime libraries that you have bundled with your application. That's the smallest, fastest Java you can get today. And that's true of both either Hotspot or OpenJ9-based VMs. So that's best you can do as of today.
I'll also share that Martin, Sebastian, there's a distroless Docker container. It's even more lightweight than the Alpine stuff. So that's like super awesome as well. Check out Google distroless if you're looking for really lightweight. And the JLink stuff is super cool. It's like almost like unikernel style, compiling your own JVM, which I found was super. It's proper niche and proper early stage, but if you really want the most performance, JLink is super cool.
Because in that way you just add literally the bare minimum for what you need for your application, and you have an incredibly small container. I've done Docker blog posts before where I show the differences for doing something ridiculously simple, taking any of the programming languages out of it, and I'm just trying to do a git clone on a private repo, and you use an Ubuntu image, and it's 85 megabytes. You do it on an Alpine image, you're looking at 6. And then you can get even smaller with distroless and further. So once you start taking out your foundation, then you can just figure out what you need for your compiling, your JVM, your Maven, and add your packages in accordingly.
There was one more hand up there, somewhere there. And maybe that's the last question because time is running.
Thank you. You said at the beginning that we could be cloud agnostic, and then at some point we have to pick a cloud, and then we go in there, and then it's difficult to get out again. Now, without becoming certified in all the different cloud providers and all the things they're going to do and what they might do in the future, how do you make what looks to be, at the moment, as a one-time decision? Which provider should you go with?
Good question. Yeah.
You've got both IBM and Microsoft on stage here.
One of the things that I really like is a lot of the customers that I've spoken with is they don't use just one cloud. They have multi-cloud scenarios, so they set up, again, in the event that one cloud goes down, and it's happened everyone, Amazon's gone down, Azure's gone down.
Yep.
I can't actually talk about IBM, but...
Yeah.
Okay.
But
I mean, so I don't think it is a one-time decision. And on top of that, so I guess another question that just popped into my head is, for anybody who did virtualization 10 years ago, that we don't necessarily consider now, did you make a decision one time, or did you rebuild your images and do gold masters or whatever it is and then reinstall your packages and update? It was never just a one-time decision. It might be right now, and in the sense of what am I going to do for the next 12 months, but I guarantee you everything in this space that's currently top of the line bleeding edge today is going to be old news in 12 months.
Yeah, and you can separate out the choices, because you know that if you go and use, I don't know, Google Vision API, you're not going to get it on Azure. So you can make those choices. And echo about what you said about multi-cloud. There are lots of, when you start deciding you want to build resilience into your system, and then you're worrying about different pods or different locations going down, then some companies will go, well, let's just literally have a different cloud provider to ensure that we've got the full resilience. And that's okay. If you're doing that and you're deploying just, I don't know, general compute, that's okay. But as soon as you start talking about moving data around, it gets expensive and sometimes impossible. And then if you use specific services, well, then you're locked in anyway. That's your choice.
Cool. I would add, a couple of things I've sort of bumped into is designing for replaceability these days helps a lot. And it's totally a trade-off, like the abstractions versus, actually getting stuff done. But I've seen, particularly for like consuming stuff off queues and things, SQS and the Azure offerings are very similar. So long as I code with, good, highly cohesive, loosely coupled, correct level of abstractions, I can actually, as an architect, maximize my options. I've learned a bunch by learning about finance over the last few years. So Amazon, the exams, they taught me about TCO, total cost of ownership. And I've also just got, because of some gigs I'm doing, I'm learning about finance models in general, but just learning about risk, about options, or a whole bunch of stuff like that, cost of delay. Not for everyone to learn, granted, but it's really helped me when I work with clients and we sort of do place our initial bets on one cloud, say, using a few financial models can really help the decision. And I do, to echo everyone's thoughts, I don't think it's a one-time shot. It does feel like a one-time shot, but I think if we kind of choose correctly, we can often leave certain options open. They might be quite expensive, but we can switch to another platform or augment our existing strategy.
Thanks. So we need to come to an end, but just as a final statement, I'd like to ask a question which maybe sounds naive to all of you, but in the end, we all touched a little bit the topic of microservices. So in the end, if we speak about cloud native, whatever that is, does this necessarily require an application architecture in the sense of microservices? Please, short statements.
I think that the monolithic days are long behind us, and so having something that is loosely coupled in a microservice kind of way, and you have your APIs like for various needs, that helps you both for scale, for growth, and then architecting out your design to where you can make those more option kind of decisions. So I think that definitely ties right along into cloud native, and pretty much where we're headed now.
Yeah, I'll echo Jessica's comments there. What I would say is we're calling it microservices now, but before it was SOA. If you look back through David Parnas's classic decomposing systems paper, 74 I think it was, I think modularization is good in many forms. We happen to be calling it microservices. I would actually recommend everyone go away and read David Parnas's decomposing systems paper, and it really just made me think better about designing replaceable components within software systems, be they functions, be they microservices, be they whatever.
Yeah, you don't, with microservices is a reflection of cloud. Once we understand that how you need to deal with cloud, how you need to deal with the fact that it's not very stable, it goes down a lot, and if you want to do scaling, all these sorts of things, microservices are really good at giving us a solution that works with the cloud economics. So I think that's why we're doing it. Is it the only option? Don't know. I think there are a bunch of people who can actually deploy things who don't need all of the big 24/7 availability, can still get cloud-native solutions. But I think in general, we're all going down the microservices route because it's the best way to exploit the cloud.
Final statement by Martin.
I still like monoliths. and the reason is because my engineering teams can actually understand the entire project or domain that they're working on. When you split things into even more than, say, 10 or 12 microservices, it starts to get difficult to take the 30,000 foot view and figure out exactly what's going on. So yes, microservices are definitely the way forward because the cloud native economics are forcing us to go down that path. Whether we'll be able to build really large systems that way, I'm not yet entirely convinced.
So what happens when you move to the next level and you've got 30,000 serverless Lambdas?
I resign.
Thank you very much. Big applause for the panelists. I hope you have all the opportunity to learn a little bit and enjoy the afternoon with lots of sessions. And after the last sessions, we all gather over there in the gallery hall to grab a beer or some non-alcoholic drinks if you prefer that. Thank you very much.